Welcome everybody to today's lecture with demonstration. We will explain Ohm's law, Kirchhoff's current law and voltage law. And we will do it by connecting a lamp to a battery, and we will also measure the current that passes through the lamp, and that we will do with the help of an amperemeter. And we will later connect multiple lamps and measure current also there. And we will see what happens if we connect several lamps with respect to the current. In this circuit, we connect one lamp to a battery, and here we connect three lamps. So three lamps are connected to the same battery, same voltage. We will see how this current will vary when we increase or decrease the voltage. We know that according to Ohm's law, we have current is equal to voltage divided by resistance. So if we increase the voltage, the current will increase. If we decrease the voltage, current will decrease. And then when we connect three lamps instead of one lamp, then we increase the resistance. Of course, then the current will decrease. So we will demonstrate that. And finally, we'll see that this voltage, suppose it is 30 volt, when we measure this voltage over one lamp connecting a voltmeter, in this case we will get 30 volt. But here we will get, maybe if the bulbs are identical or very similar, then we will get 10, 10 and 10. So we will use a voltmeter to measure the voltage. So basically the demonstration that we are going to show you today, there we will see a power supply, that is a battery. We'll see an amperemeter, a voltmeter, and then we will see how we use these instruments to measure the current and voltage. We'll also see the relationship between voltage, current and resistance. Thank you. Alright, welcome to the experimental part. Now, let's look at the instruments that we are using here. First of all, this part, this instrument at the bottom, this is a power supply. You could think of as a battery where you can change the voltage. Here you can read from the display the voltage that you set. So this is basically a variable power supply. The instrument at the top, we call it a multimeter because you can use it for measuring multiple parameters. You can measure voltage, you can measure current, you can measure resistance, both direct and alternating. In this experiment today, we will use this to measure current, and then we call it amperemeter. And the yellow one is also the same, a multimeter. We will use to measure voltage, so we now call it a voltmeter. And we have here a bulb, and the bulb has a specification which shows its effect. The watt shows the effect, the capacity of the bulb, and it also says the maximum voltage that you can connect. You shouldn't exceed the permissible voltage. Good. What we will do now, we will connect from the power supply. Let's say we will take 15 volt from the plus end and minus end and connect this to one valve. And as we connect, you see the valve is turned on. The valve is turned on. Now, if I now decrease the voltage, and that can be read from the display there, to 10 volt or even up to, let's say, 5 volt, then what you see that the lamp is not visible really. You don't see there is little current, but you don't see the lamp is on so much. Now let me go upwards. So we increase the voltage now to 20, let's see. You see bright light. I can continue furthermore to 25. You see strong light, and up to 30. You see very strong light. Now we want to measure this current and also the voltage. Now see, I have 15.6 volt and I want to measure the voltage. Then I connect my voltmeter across the lamp and I see the voltmeter shows also 15.6. Actually it shows 15.7. Let's see again. 15.7. The power supply shows 15.6 and the voltmeter showed 15.7. There will always be some difference between the instruments because of their different quality. Now we want to also measure the current that is passing through, and how do we do that? Measuring voltage, you just make sure that you get the same voltage. So the voltmeter is connected to the same voltage that is across the lamp. Now for measuring the current, the connection should be a little different. And how is that? We want the same current to pass through the amperemeter that passes through the lamp. And that means we need to connect the amperemeter in series. So same current should pass. That means we need to connect in series. That's what we do. So we have connected the amperemeter in series. So we have the same current passing through the lamp as through the amperemeter. Now let's see what happens when I increase the voltage to, now when I'm at 15 volt, the current is 53.6 milliampere. I increase this to 20, it has increased to 64. Excuse me. Now when I increase further to 30 volt, then I get 81 milliampere. So as I increase the voltage, the current increases, and that agrees with the Ohm's law. Now I will connect 3, as I showed in the picture on the whiteboard. I want to connect 3 lamps in series, which means 3 lamps will be connected to the same voltage, 30 volt, in series, that means the same current will pass through them. So I connect them in series, that allows the same current to pass through. Now it's interesting that when I connect 3 lamps, I see the lights are not as bright, and I see that the current is only 41 milliampere. So current has decreased, and that we can see from the lamp that they are not as brightly shining now. Now, so what we can say that if we increase the number of bulbs, that means we increase the resistance, and if we increase the resistance, the current will decrease, and that also agrees with the Ohm's law. And at last we want to see how has this voltage 30 volt, how has that been distributed over the lamps. We have 3 lamps connected. Now if I measure the voltage over the lamps, here I have about 10 volt, 10.2, here 9.7, and here 10. So we see that we get 10, about 10, 10, 10. So in total we have 30 volt. I also want to show you what happens if I, for example, disconnect one bulb. We see current is 0, and we see that the bulbs are off. Now let me remove this bulb totally. Now if I measure the voltage, I will see 0 volt here, because there is no current flowing in the circuit, 0 volt there. But what happens here? Here is not 0. Here I get 30 volt. So although this bulb is not there, it's removed, but the total voltage is now here. So in the circuit, this voltage is now over the empty space. Why? Actually, because we see that this positive pole is connected through the cable here until this point, and negative pole is connected through this bulb until this point. So basically the plus and minus pole of the battery is here, because electrically the whole cable can be considered as one point. So we could say that the plus and minus poles are here. So this 30 volt is here. So that we should be very careful about. We should not think that there is no voltage. This can be very dangerous when we are working with high voltage. Alright, I would also want to show you what happens and how it looks like when we have parallel connection. But that will be done in the next film.